So my name's Luke Stuber. Work here in the research and development group out of the Tremont office with precision planning. And then, so myself, and then there's going to be a group of us come up. This session is going to be a little bit different than the other ones that you attend. We're going to cover a wide range of topics. We're actually going to go from drainage to soil fertility to soil density. And at kind of at a high level, there's been this question asked, like, does this all fit together? And really what we want to focus on today is things that you could do on your farm right now that we believe have the highest return on investment of any of our other practices. And so really, we just want to get you thinking. And we're going to do that through kind of a number of practical stories and then just some other insights that we've gathered. And so when we think about our farms, you know, there's farms that we have that we know a lot about. You know, this example up here, I've got a lot of years of yield history from it. I've got multiple sets of soil sample data. I know where the high fertility areas are, the low fertility areas, the high yield areas, the low yield areas. I know where the wet spots are. You know, on a farm like this, really, I have the data. I just need to implement some practices. I really just need to execute. And so if you guys have farms like this, take a look at the data and then try to implement some of the things we talk about. There's other farms that really the only thing we know is what they look like. And so a farm like this is like, how do we shorten the learning curve? How do we take a farm that we don't know anything about, implement some new practices, and really help get that farm up to its optimum yield? And this is actually what I'm going to spend my time talking about today. This picture I have up here, this is actually a farm that I picked up last winter. And so I got an agreement in place in February. And so I had this, 2 to 3 month window before we planted the first crop. And so the thought is, what can we do? Or what needs to be done? And so for this particular farm, the first thing that was pretty obvious we needed to do, we need to remove some trees. The waterways were overgrown. There was enough trees in those waterways, you actually couldn't farm through the field. You had to farm around them. The south fence row, there was half a dozen trees along there the trunks were out 20 feet in the field, let alone the branches hanging out. The far east side, we had 20 to 30 feet of bush honeysuckle and honey locust. And so this was the first thing that I did, starting in February last year. So we got those trees removed before the first crop went in. That was an obvious thing, very noticeable, will have immediate impact, made sense. What about the other things that aren't so obvious? And that's the fertility and the drainage. In this case, from a fertility perspective, I was suspicious this farm was in bad shape. But once I got a little data, I was able to prove that. So I, working with the guys here on Radical Agronomics, so I got the app from them, set it up, went out, took the soil samples myself, brought them back here, ran them through the lab, and now I've got my results. And you guys, you can see, like, this farm is in tough shape. Very low phosphorus and K values, pH is all over the board. So, we need some significant amounts of phosphorus, potassium, and lime to get this farm in shape. The thing is with this farm is, when I look at current fertilizer prices, it doesn't make sense for me to go attack this all at once. And so I'm looking at this is going to be a multi-year project. And so I've started that process this fall after we got the crop off, but it's going to take a few years to build this soil fertility up to a point where I feel like that we've reached kind of that maximum or optimum potential. What about drainage? This one's even harder. If you have a lot of years of data on a farm, you know right where those wet spots are. But how do we learn quickly on a dry year, which we had last year? This particular farm, there's a lot of roll to it. So I wasn't worried about ponding. Standing water wasn't going to be an issue. But this field is a fairly white timber soil farm. And here, kind of in central Illinois, if you have those type of farms and you've got hills, you know that you've got areas where the water is going to seep out of those hills. And so how do we find them? And so what I want to actually talk through is kind of what we have done on this farm from a drainage standpoint over the last year. How do we shorten this learning curve? In this particular case, I did know there was a little bit of tile in the farm. When I had looked at it, I had found an outlet back in the timber, and I had also found a big tile hole up by the road. So I knew there was water draining both directions. I just didn't know where the tile was or how much was there. I actually started with a call to the previous tenant, and he was generous with some information, and he provided me a hand-drawn tile map. But I don't know, guys, how many of you have ever tried to actually find tile based on a hand-drawn tile map? I mean, it's almost worthless. The beauty is you do know that there's tile there, so you can at least prove that to yourself, but nobody draws anything to scale. And so this is a start, but it's just a start. There's still some work that needs to be done. One thing that I started doing a number of years ago is actually using historical imagery out of Google Earth to look for tile lines. It doesn't always work out, but if there happens to be an image from the right time in the spring, right as your farm starts to dry out, you can see those lines at times. So this is actually an image from 2014. I'm going to highlight it here to make it a little more obvious. You can see every one of those tile lines from that image. So guys, if you have fields that you're questioning where the tile is, go and look. I mean, it's not 100% for sure, but this has worked on quite a few fields. I've looked at a lot of farms, and this can be really beneficial to you. The beauty is if you can find an image like this, you can use geolocation services off your phone or iPad and actually walk out and get it within 5 to 10 feet of that tile. So from that point forward, probing or digging gets a lot more simple. So just for kicks, I actually overlaid that hand-drawn map with the actual map. And whoever drew this actually did a pretty good job on the north side of the farm, but on the south side, I mean, a couple of those lines are off by over 300 feet. And so that Google Earth image saved me a lot of work of locating those existing tile lines. And so now this gives me a baseline. This gives me a starting point. I know where the tile is. I know how much is there. So that's a great place to start from. The other thing that I've been doing is, especially on a new piece of dirt, there's always a day in the spring right as your farm starts to dry out. So those first days as things gray off, you get to the point where you have 75, 80% of your field dried out, and you go out and scout, walk, drive, maybe fly it with a drone. You can pick out those last areas of the farm that are still wet. So in this case, I actually drove it with my UTV back and forth, and I dropped pins every time I went through a wet area. And what you can see is there was a cluster of high moisture area down in that southeast corner, and then kind of on the west side of the farm, right in the middle, there was another area of wet. And so now, using this map, I know the areas of the farm that dry out last. So I know the wettest areas. The other thing that happened last spring, you could say this is fortunate, you could say it's unfortunate, but I put the beans in. A week later, we got 4.5 inches of rain. Then the sun came out, baked it, and turned it to concrete. And so I had a really, really poor stand of beans in places. And so I had to go in and do some replanting. Ended up replanting about 15 acres of this farm. But I think the thing is this is another data layer that I can use. And so if I look at this, if I look at everything that I know at this point, I know where the tile is, I've marked the wet areas, and now I've got my replant map. If I look at that all together, what do I see? What I can pretty quickly see is that the areas that I marked as wet are where I did the majority of my replanting. Not all, it's not 100%, but that's the majority of the replant that was needed. But that also aligns with the area of this farm that wasn't tiled. So the interesting thing with last year, as you all know, is after we had that big rain in the spring, we never had rain again. I mean, we had some rain, but we never had excess moisture. Maybe that's the right way to say it. And so in this case, these wet areas did not show up on the yield map. I did not take a yield hit in these areas. They were actually some of the higher yielding areas of the farm. It's where some of the better soil is located. And so the question is, what do I do? Typically I've used yield maps in the past to do a lot of our tiling, but in this case, the yield map didn't support that, but all my other data did. I knew there wasn't tile there. I knew it was the last area of the farm to dry out, and I knew I had to replant. And so do I execute, or do I wait to try to gather more data? A number of years ago, I was involved with a conversation with an older farmer here in the Tremont area, and I still remember this distinctly. We were talking about tiling, and he said, Luke, whether you install tile now, you will pay for it every year. Whether I install tile today, pay my money up front. If I don't do that, you're still going to make a payment on it every year. And you're going to make that payment in lost time, productivity, could be yield. In this case, I had to go back and replant. That's not free. And so on our own farm, back in 2019, my brother and cousin and I decided, we are going to start taking care of this. We're sick of dealing with these sorts of issues year after year. And so we actually bought a tile plow, set it up with a PTx Trimble WM drain system, and we started tiling. And so on this particular farm, so after we got the soybeans off, we went in and tiled those areas of the field. So we pattern tiled, selectively pattern tiled the southeast corner, some of that area up in the middle where that draw was, and then the whole kind of center section on the west side of the farm. And so in 1 year, using data other than our yield map, we went in and tried to fix this farm. Now, did we get it perfect? It's probably not. But did we get 95% of the problem fixed? Probably. If we need to go back in and add a line 5 years from now, we can do that. But what we tried to do is use the data that we have to fix it before it becomes this big yield drag. And so in this case, on this farm, we ended up adding about 10,000 feet of tile. This was a combination of 4-inch and 6-inch. The beauty is once you have the equipment, the cost and time to do this really isn't as big as you'd think. In this case, if we look at all of our material costs, so this is the tile and all the fittings, we had about $4,500 that we put into it. From a time perspective, and this is where a lot of guys are saying, I don't have time to tile. And I agree that it is a time commitment, but in this case, myself and one other guy did this in 1 day. Now, I knew where the existing tile was to tie into, so that's an advantage, but it took us, we were out there, it wasn't 8 hours, we were probably out there 14-hour day, but it was 1 day. We weren't out there for weeks taking care of this. And so for really 1 day of effort and $4,500, now we've fixed this drainage issue. And we don't have to continue dealing with it every year thinking, wow, I really should do something about it. You can do it now. We think about it from an equipment perspective. This is another kind of pushback of guys saying, hey, I don't have the right equipment. The most expensive piece of equipment you need is your tractor, which you've already got. The other stuff, it is an investment, but it definitely has paid off. I feel for us on our own farm, aggressively attacking drainage issues has probably been the biggest return that we could possibly have done. We have dramatically changed some pretty rough farms by adding tile. And so in 1 year, we're getting ready to put the second crop in this spring. This farm is on its way to being a much better farm or achieving its max potential. We did the obvious things with the tree removal, fertility, right, multi-year thing. Josh and Doug are going to be up in a little bit to kind of talk through, hey, what are optimum ways to do that fertility? And then we've attacked the drainage, which is probably this kind of the single biggest issue on this particular farm. In fact, I'm going to have Josh Eide come up now, and he's actually going to try to walk through some of the software and tools that exist that really enable us as farmers to do tile installation. I mean, GPS has changed the game in this space, and he's going to try to walk through, give you a better picture of what it takes to do that. So Josh, why don't you come on up?
Thanks, Luke. My name is Josh Eide. I'm a part of the strategic marketing team here at PTx. And I've had the opportunity to spend a lot of time with our water management systems. And as he explained, I'll be talking a little bit more about that whole process of how you use that system to install drain tile in your field. So we all know the challenges of dealing with water. Luke outlined some of it. There's too much, there's not enough, it's the wrong spot at the wrong time. But we can use those PTx Trimble guidance systems that we have on our tractors today to do water management work and install drain tile in your field. So the first step is moving the receiver from the top of the cab to the tile plow. We're using that same display in cab. We are adding some valve control components just to control the tile plow in your field. And one other thing that you might need to add is RTK corrections. So you'll see that corrections radio on the diagram here. We add that along with that base station in the field. And the reason we need that is because your vertical error So anytime you're doing up and down work with implements, that vertical error is twice as much as horizontal error. So if you're using a guidance system and you see a little bit of a weave going down those rows, it would be twice as bad for any of the work that you're doing underground. The other thing you have is the farther you are from your base station, the bigger your error gets. So it's important to do that work as close to your base station as possible so the water is exactly where you want it to be. And the process to install the drain tile in your fields can seem intimidating, but it's really only 3 steps. So we start with surveying the field. And there are a few different ways we can do that. I'll go into that a little bit more later. But once you have that data, you can design each tile line. And we have some tools to make that easy as well. Once you have those designs for each tile line, you just install them in your field. And our system's controlling that tile plow automatically to make sure that the tile is exactly where you want it. This is a quick screenshot of the survey screen, and it'll guide you through the whole process. And surveying the field is really just driving around the field, getting the data you need so you know exactly where the surface is so that your drain tile gets put exactly where you want it. It could be recording the interior points, boundaries. If you have the data from the scouting work that you've done, like Luke outlined, you can just directly survey those tile lines where you want them to be. And you might not have that window of opportunity in spring, or it might be a really dry spring where you can't get that data and scout the field and know exactly where those trouble areas are. When you survey your entire field, you get that information. You know exactly where the high and low spots are and the areas you need to tackle first. There's an area in the field behind my dad's house. So it's on his farm, and it's only wet every 10 years. So those really, really wet years that we deal with once in a while, there's a spot that only shows up then. And without either that perfect timing or getting that full topographical data for the field, we wouldn't know where those are. And you can see them on the left-hand side, just gathering those points as you drive around. On the right-hand side, we're using that data that we have from the scouting work and just surveying those tile lines that we want to put in. So it's a really fast, easy process, and it's really straightforward. Once you have that topographical data, you design each one of those tile lines. So it might seem intimidating as well. So there's a lot of information that goes into it, but we've made that a straightforward process. We have a feature called auto slope that with a few inputs will design the profile of that tile line for you, and you can see it here. So we have our minimum depth, so it's as shallow as you ever want your tile to be, that optimal depth where you really want it to be, and that maximum depth. And that max depth might be as deep as your tile plow can go. It might be just the capacity of the tools that you have. Then you have your minimum slope. So it's taking all of those data points and building that tile profile for you that you'll be putting in later. And if there are any errors, they're highlighted on screen as well. You can look at those, see exactly what's wrong, make any changes you need, and make sure and ensure that everything is where you want it to be. And even if your tile design is as complex as the one you see here, and that's definitely more than 10,000 feet of tile and more than one day for a couple of guys working, but you're using that exact same process and you use the exact same equipment to do that work. And once you have those designs completed, you're driving through the field, installing the tile as you go. The system's automatically being controlled using that receiver on the tile plow, and this is what it looks like on screen. So it's telling you exactly where you are, like as you're driving your tractor through the field, and it's telling you where your tile is going into the ground as well. It's giving you both pieces of feedback as you go, and while you're doing that work, it's recording the position of that tile in the field. So no more going back to hand-drawn maps, forgetting where it is. You have that as a reference point going forward. And even if you're doing the control work manually, it'll grab that data and record that for you so you know where it is. And any system that you have, so if it's the one that we see on screen now, with a direct mount tile plow, a hitch mounted plow like the one next to us on stage, if it's a ditcher, you can do the surface work, it will control the system, or if you're using a self-propelled plow or like a trencher, it will control all of those, and it's using that exact same system. I've got a quick video of some first-time users in a training session for a field at Ohio State. We went through the exact same process I just outlined. So surveying the field, designing each of those tile lines, and this is of them installing that as they're going through the field. This is a field that they use every year as part of their ag college. And like I said, these guys are brand new to it, and it was really straightforward. So it's absolutely something you can tackle in your fields and make an immediate impact. And now Doug will be coming up and talking more about improving the fertility of fields and some of the experience he's had with that process. There you go.
Thank you, Josh. They asked me to talk on managing nutrients. And I've been around here a little bit, and I've been around managing nutrients for a few decades since I was a kid. And my first memory goes back to when I was 4 to 5 years old, riding in the big wheels spreader truck with my dad. They'd custom apply and apply for their own farm potash and potassium, nitrogen, ammonium sulfate. And then Mom had the end loader. The Alice Chalmers end loader, we'd spread lime, and I remember riding in that end loader with her. You know, at 4 years old, you can fit in spots they don't make seats. Back then, they didn't have seats, buddy seats, right? And then I remember my grandpa telling me the story. My dad, early days, pre me, this was prior to when I was born, in the 1950s, if you drove around and you watched people put anhydrous on or put nitrogen on application, it was with one of these. It had an applicator with knives to knife it in. You could see there was nothing to seal it. Probably had some that with, some without. But they had a mounted tank. And then you got your transfer tanks behind there that they'd pull to the field, and they'd transfer that anhydrous to that mounted tank. They'd go out there, apply it, and then they'd go back to the side of the field and transfer it again. How much longer would that take? And you're thinking, well, this doesn't make sense, does it? Why would they do that? Well, at that time, that was probably pretty productive compared to what they had done before that. And my grandpa said him and Uncle Henry had the idea, at that time they started a business in Goodfield, Illinois, called Wiegand Fertilizer Equipment Incorporated. They had the idea to build a bar to pull a tank through the field instead of transferring that anhydrous. So they built these bars, and they said, man, they just was selling like hotcakes. Couldn't keep up with it. So they built a single bar. I went out on Big Iron, and I found what I believed to be a Wiegand bar. A single bar instead of a dual bar. Now today they got dual bars for better ways to do clearance, stuff like that, and knife with spring-loaded shovels. That predated the disc blades out there. And so that's where it all started, back a few generations ago. And fast forward, I come to precision planting, and a few years ago, Corey Mulbauer and Aaron Herman, the R&D agronomy team, worked with the University of Illinois to do N15 plots. Well, what's N15? Well, naturally, nitrogen is N14, the atomic weight. And what they have learned in science is that if you change it from N14 to N15, you can actually trace that. So in other words, if I put it in the soil and then I take the plant and I measure the nitrogen, break it down, measure it in the plant, I can actually trace what percentage I applied got into the plant. And so they went out there, they worked with Tim Smith, who's an agronomist, owns CropSmith Incorporated, and they put in small plots because it's pretty expensive, and they broadcast and then they banded. And then they took, when that plant material, when plant was grown up at harvest time, they took that plant and they cut it off short to the ground, and they ground all that material really fine. And then they took it into the lab at University of Illinois, Dr. Mulvaney and Kelsey, and they ran it through the mass spectrometer to actually measure how much of the N15 that was applied got into the plant. And here was the results. When I broadcasted it and worked it in, didn't just broadcast it, but broadcast it and worked it in, so you didn't have a lot of volatility. 16% of that N15 got into the plant. When we banded it, knifed into the soil, 3 inches over, 1 inch down, just like a concealed dual band, 34% of that nitrogen got into the plant. And then for giggles, they went ahead and they dribbled it out the back with a drag chain, because that's what we did on our farm for a few years. Why? That's the cheapest nitrogen application tool, right? Saves money. Only 26%. So it was better than broadcast, but it wasn't as good as when you knifed it in the ground. So it was double the efficiency. Well, today, what are you and I looking for if we're farming? We're going to write a check for some nitrogen and some corn and some soy, all this stuff. How do we increase net productivity per dollar spent? That's the name of the game. And then at the same time we did that, we hired a guy by the name of Jason Webster. And Jason had this idea to start these plots up in Pontiac, Illinois. And so right out of the gate, in 2017, he started creating nitrogen placement plots, where he would test nitrogen single, dual, and triple treatments. And this was the first couple years of those multi-year studies. On the right-hand side is 100% weed and feed. Just like in the N15 studies, what did it show? Not only did it show that not as much of it got in the plant, but it wasn't as effective as far as ROI either, was it? And so in the middle of the graph, you had that dotted bar. That's 50% weed and feed, 50% side dress. And that was much better than just weed and feed, right? So banding, along with the weed and feed, quite a bit higher return for the same dollar spent in total units in. And then the winner of that plot was 25% weed and feed, 25% through the planter, through conceal, and 50% side dress. Now, if you look at that, the top 1, 2, 3, 4, 5, 6 treatments, the top 6 winners had planter applied nitrogen. Right? We fought that on our farm for a while, and eventually we gave in, and I'm going to tell you, it just pays. And in 2019, what did we see? Same thing. A bit of broadcast, 25%, 25% through the planter, 50% side dress. All 3 years won the study. And so as much as it was a $60 per acre advantage over weed and feed and side dress. So if you're broadcasting and side dress, and we did that for a number of years, this here was a $60 per acre if you farmed in those 3 years in Pontiac, Illinois. In 2025, with higher inputs and lower commodities, it still paid. It still was a $20 per acre winner. Why is that? Well, the power of concentration. When we ban nutrients, how much of those nutrients we've put enough of a concentration in one band, how much of that gets tied up by the microbes? Not as much. You see, you got the surface area and that's it. When I broadcast, what happens? Well, a much higher percentage of those nutrients, whether it's nitrogen, phosphorus, potassium, it gets tied up by the environment, by the microbes, by the complex carbon chains. They call it the carbon penalty. So as we look at the corn plant as it grows and its needs on nitrogen uptake, early on, from germination to V6, there's not a lot of nitrogen that corn plant needs. But that is a very common time that nitrogen is highly fixated or highly immobilized by the microbes, because you have residue out there in the soil that's more complex. It's not as broken down. So you see net immobilization of nitrogen out there, not net mineralization. So therefore you're fighting with that. And so that planter applied nitrogen shows in every study that it helps to supply that plant during that tie-up period. And then the next phase is that rapid uptake, right? And in that rapid uptake, the studies all show that the environment isn't mineralizing enough nitrogen per day to supply the needs. And that's where side dress with the culture really comes in and spoon feeds what the environment's not going to supply. And then what the 25% broadcast shows over and over and over again is that speeds up the breakdown process of that carbon breakdown that those microbes have to do, that it starts to mineralize towards the end of the season after the side dress, that helps to finish that off. Pre-plant broadcast drove that. It's cause and effect. So a few years ago, the engineers designed a rate module to be able to control a pump on a planter. We can apply liquid. And just this year, they've developed the software to be able to do any pump on the market, including a servo valve, a butterfly valve. And then, so now we can get the right rate per acre, right? But what happens when we see this? Any of you ever see this in your fields? Never, right? Wait a second. Is there one knife or two knife that got plugged there? And so that system used a floating ball flow meter, right? We all have seen them. We've all used them. And a distribution manifold, just like what you see right there. And so our engineers designed a flow sensor to put into the 2020. And we went out there and we started measuring row by row. And in that row by row, what they found is that there's quite a little variation. On even the good implements, sidedress and planter, many times they would see a minimum of 15% variability, row to row to row. Well, how's that work? 27% over 10-gallon variability. And then, with those old systems, what are we doing? Well, we're running through an orifice, right? There's an orifice in every row after the distribution manifold, and that's going to make sure we get the right rate and the right consistency. And what happens in an orifice-based system when I speed up beyond what it was targeted for? Well, I apply less. What happens when I slow down? Well, I apply more. How much? Quite a bit. 21% variability within that field just based off planter speed, right? And so the engineers designed a ball valve system called EMHD and an EM electromagnetic flow meter called EM FlowSense to work on every row. So now on every row we have a flow meter and a ball valve controlling to that flow meter to get the right rate at the right time and consistency from row to row to row. So it drives application uniformity, right? We want to hit that luxury consumption. How do we take every dollar of input that we're investing and maximize return, not just per acre and not just per row, but plant by plant? So with the 2020 SeedSense, the modular capability of adding a rate module, taking over control of the pump, and then adding the row by row is a very economical way, a cost-effective way that you're not throwing dollars away, but you're just adding capabilities year in, year out like we've done on our farm. Thank you. I'm going to turn it over to Josh Stoller.
Thank you, Doug. So how do we make this profitable? Actually, within the last 2 weeks, I got a text message. And it said, I don't know why people farm in this environment. It was about one of the most farmer things you could say. So I'm thinking, how do you respond? You know, kind of thinking some smart aleck thing to say. And before I had time to reply, he goes, inputs versus $4 corn, property taxes, it doesn't math out. So I'm thinking, like, it doesn't math out. That's not even proper English. So I'm thinking, I sent back, well, Dollar General's hiring. What else? The reality is, it doesn't math out. It's like Jason Webster laid out first thing. With the economy that we're in, prices down, everything else up, it doesn't math out. So I pulled the same numbers that Webster had earlier. When you look at current Illinois farm docs, income, the top section there is income. And everything else is our expenses. 25, 26, those are projections, estimates, see where things are coming in. Yield or price per bushel. 634 high average to 415. I just checked this morning, we're even at 399 locally. Cost of things, fertilizer. This is where we're going to spend a decent amount of time. This is over a quarter of our inputs typically, of all of our fertility. Went from 143 to 229 an acre. How can we afford that? Chemicals, herbicides, pesticides from 76 to 112. Interest, 14 to 37 bucks an acre on interest. So what does that do for our return? We used to be able to make money. Now they're projecting a negative 82 an acre. So how do we tighten our belts? Is it just taking inputs and lowering those? Are we still shooting for higher yields? For us personally, almost everything we do is ROI driven, right? It's nice to hit high yields and record yields, but if you don't make a profit doing it, what's it worth, right? So it's interesting when you look at Webster, when he's looking at banning fertility and cutting fertility, and we had a lot of discussions over the summer where he's like, should we, for the first time in a long time, think about zero? Nobody wants to do that. You feel like you're not being a good steward, but there's a lot of times where maybe we should consider that, right? If we have fertility that is in abundance, okay? So the reality is it doesn't math out. In this environment, it doesn't. So how are we going to tighten our belts? We asked 3 questions. Fertility-wise, where are you at currently? Second one, where do you need to get to? What is your critical level of those nutrients? And the third one, how and when are you going to get there? If we've got a field that we know we need to build, is this the year to build? I don't know. Okay, so we had this one. We started farming in 2020. This is an elevation map from Panorama. And you can see the darker red areas, that's kind of a hilltop. And in the gray areas, that's where it gets low. So that's typically higher organic matter. That is where water is going to pond if we get a wet spring or wet summer. So, interesting here, when we first started farming this, the guy told us, he's like, you guys are going to have some work on this field. He's like, we have not soil sampled it or applied lime in 10 years. Okay, so we're pretty sure we're going to need some lime. We're pretty sure we're going to need correcting. So our question was, where are we at? Where are we at with lime? Where are we at with fertility? So where do you want to be with lime or pHs? Our goal is roughly around that 7 mark. Okay, if I go from a 7 to a 6, so over time, this will drop. Question is how much, and how much is going to need to correct. Okay, if I go from a 7 to a 6, that is 10 times more acidic. Okay, every number you drop down multiplies by 10. So a 5 is actually 100 times more acidic than a 7. Okay, so we said it has not had lime in 10 years. What are you guessing that lime values are going to be? I don't know. I'm sorry, not lime values, pH values. Our pHs might be in the 5s, buffer pHs in the 6s. Who knows? We're going to need lime. That's what we knew. So we got it soil tested. And where did our pHs come back? Our buffer pHs were like, sweet. And the guy comes back and he's like, it looks good. You don't need lime. And we're like, after 10 years of no lime, we still don't need lime. That's what it shows. Perfect. So field average, 7.2. And we took that as a win, right? We don't have to put on lime. And we didn't. Okay? So we started, the following year, that was 2020. The following year in 21, we started working with advanced agrolytics. And we said, hey, last year we kind of had this doozy, this field we expected to put on lime. Could you just double check that? So we had them sample that in 21. And what did the results come back? So this is a year and a half later. We get these samples. We look at our pH, buffer pH here. Look just to the left of that and our pHs. And we're scratching our heads. We're like, that's what we thought, right? This is what we thought. So now we've lost a year and a half. The last guy said we were good. These guys said we're way low. So what do you know logically? Probably this is right. This is what we thought. Okay? So then you're scratching your head and you're like, well, what do you tell the first guy? Or you just sit there frustrated and internalize that and then just... Okay, so this was the samples from the second one. On the left, that's our pHs, getting all the way down to 5.1. And then with the buffer pHs, you can see in the low spot, there was one little green spot that did not need lime. So what did our lime rec look like? we had a huge chunk of the field that needed 4 ton. Are you going to do that in 1 year? No. So we're splitting this. We did a 2 ton max, and we split that over 3 years. And what we come to find out was this whole thing was just flat out an epic fail. And we're like, what happened? How were we so far off? And then that begs the question, what were the other fertility values like? Where should I have been on other things? And it's like, is the whole thing wrong? Or is just pH is wrong? Like, what are we doing? Okay, so we go back, and actually in 22 then, we started having a lot more conversations around trustworthiness and repeatability. The thing is, when you look at precision planting, why we spend so much time on fertility, why do you think we're spending so much time on radical agronomics and an autonomous soil lab that's repeatable and accurate? This is why. And we look too, where should that was question number 1, where are we at fertility-wise? Question number 2, where should we be at? Okay, but we back up. There's actually a company, Agriculture Lab Testing Association. What they do is they will go from soil lab to soil lab and test them. What is their accuracy in different areas? So the first lab we went to, we were like, which ones pass and don't pass the buffer pH? Because that's what we just based the last 1.5 years on. The first lab we went to was this one. Did not pass. I wish we would have known that in 2020. We did not. Okay, the second lab we went to happened to have passed that one. So now we've got trustworthy results. Now we can do something off of it, and that since then has been corrected. And we're in a lot better state now than what we were back then. So our other fertility, where do we need to be on phosphorus and potassium? University of Illinois data says on the bottom there, you see the high, medium, and low. That's basically the high producing soils. If you are in higher organic matter, typically lower lying soils, you will need a lower critical level. They would say 40 pounds per acre or 20 parts per million. Okay? Potassium. University of Illinois says if you are in lower CEC soils, a goal should be 260 pounds per acre. So we're going to use those as our goals. Potassium, 40 pounds, or if you think in parts per million, 20. Just divide it by 2. 20 parts per million equals 40 pounds per acre. Okay, same thing with our Ks. So we go back to the second soil samples that we got and said, where are we at? Our P values, again, we knew we needed to build some up. They hadn't soil sampled or known where things were at in 10 years. So looking at this, the goal being 40, where were we at? Low, some areas in the 12s. Luke's example, they were in the single digits on a lot of it. So the reality is we have areas now that need built up. Do you do that in 2026? That's real questions that we're asking. And how do you best build those up to where the crop responds to that, but you're not over applying and throwing away money? Okay? So in general, we were low, some areas a lot worse than others. This was the map. This is a soil map on the left, and this is how we're fixing it on the right. This is our variable rate application of P. Then we ask the question, are we doing that all in the fall with a broadcast? Are we going to split that up and move some to the planter? And we do. Okay? That's the whole point of this discussion. How do you make it the most efficient to where you know that we are deficit and you want to bring that up in a tough year? This is literally a question that we all face. And we've got to know where we're at and is that accurate? Okay? Same thing with our K. Come to our Ks. What was our goal? Roughly 260 per the handbook. This field average 190. So we've got 150s, 107s, some of the lower ones. There are some areas. Look at the top one, 434. There are some areas that were fine. And when you look at Jason Webster's, when he's doing the strip trials and cutting fertility back, Anybody remember where he started off at? He started with a p-value, our goal is 40. His was at 66 field average. Our K goal of 260, his was at 363. So it starts making sense. When he goes to 0 and he's still yielding high, that's why. He's got a field that he can actually draw back on, but he's in the 5th year and starting to see that coming down. Where does that tell you where his critical level's at? Right? These are things we've got to think through. Don't just blindly order a 200 application. We cannot afford that in years like this. Okay? So this is our K map, the soil samples, and actually we lowered our goal. Illinois would say 260. We lowered it to our critical level of where we need to be. And this on the right is what our fixing it application looked like. So, boiling it down, this is the Tri-State Fertility Handbook. They say, if your soils are below the critical level or they are deficient, which is what we had, what should you do? These are from the agronomists saying applying 25 to 50% of the recommended fertility in a band is recommended to enhance growth, right? Why would they say that? It's flat out logical. When you put it in a band, we've got the proof for years and years. Nitrogen, phosphorus, potassium. Webster's proving it now. We've been proving it for years on nitrogen. If we are not currently banding, this is the point. This is the whole session's point. If we're not currently banding and managing the soil density, now is the time. When we're in an economy that does not math out, this is the time to get more efficient. Is that cutting the total rate? Yeah, probably. That's what we're doing this year. We are applying less. We are continuing to apply in a band. So what are the options for applying in a band? And it may be, I would assume that this room has a lot more banding and efficiency than typical farm. That is a general assumption, okay? What are the options as we self-reflect and say, am I banding enough or appropriately? They say 25 to 50%. Jason Webster said, you know what? 75% or more is where we find the sweet spot of nitrogen specifically, okay? So in the fall strips, these are what his trials are. Fall strips, dry, typically your P's and K's instead of a broadcast. Spring strip till. I've got some guys down south where things are warmer and they're worried about nitrogen being gone. They're going to put nitrogen on in the spring in a band. On planting, we've been talking about this for years. This is still one of the lowest hanging fruit. It is not difficult to put nitrogen or in furrow, typically a phosphorus starter, on the planter. These are the years it's like, well, that costs money. Yes, it does, but it makes more than it costs. Still at $4 corn. And then sidedress. This is typically nitrogen or sulfur or boron later in the season. So we know where we're at, soil fertility. We know where we're going. Now when you go to fix that, this is where we've got to know, am I actually applying the right amount? This is why we spend so much time on dry clarity. Understanding, do I have a row that is half blocked or fully blocked? You can know that immediately instead of finding that in strips in the crop like Doug showed. We do realize fall and spring anhydrous is a point that we do not have a lot of visibility, and we're looking into that. On the planter, we can see and control about anything. This is a phenomenal place to be banding fertility. On ours at home, we're putting nitrogen and ATS mixed in the tank on the planter. That's going in a 2x2 application, and then on the front of the tractor, that's where we'd have a 722.5, more phosphorus, where we're pulling from the fall and we're applying in furrow on the planter. This is where efficiency comes in. And then the last one, typically nitrogen related. If you do not have the ability to come late season or even on the planter, it is worth, especially this year, saying, hey, my neighbor does that. Could you come do a strip or a half a pass or something like that? I want to see, is this something I need to be looking at? Used equipment, you can find things now. right? So at the end of the day, the reality is water management, density management, and fertility management, these are the things that we continue over and over and over. This is the lowest hanging fruit. When we've got to tighten our belts and get more efficient, this is how you do it. And when that gets done, you will hit the goal of getting a phenomenal root structure that's exactly in the band and pulling up the nutrients, like what Webster's doing. When you got them harvesting light, those are pulling. And if you've got a band where those roots are at, that is where you will see yield increase and inputs start going down.